You know that person who can just look at a massively complex problem and instantly know the answer? It almost looks like they're performing magic, right? Well, today in this explainer, we are tackling that captivating mystery of true genius level intuition. Because what if this seemingly effortless intuition isn't magic at all? What if it's actually a mechanical, structural process that we can completely replicate? To really set the stage here, the mathematician Mark Koch once famously said, "There are two kinds of geniuses, the ordinary and the magicians. Even after we understand what they have done, the process by which they have done it is completely dark." Now, Koch was actually talking about his colleague, the legendary physicist Richard Feynman. To everyone around him, Feynman was the ultimate magician. I mean, he could solve physics problems in a matter of minutes that had stumped other brilliant minds for literally months. His mental methods just seemed totally inscrutable. But today, we're going to see if we can decode them. Our whole journey today is grounded straight in our source material, which is the book Ultra Learning by Scott H. Young. Specifically, we're going to dig deep into Chapter 11, which is all about Principle 8, Intuition. We are going to break down exactly how Feynman's intuition functioned behind the scenes so you could stop just memorizing textbook information and actually start applying these exact same techniques to build your own deep understanding. So Section 1, How Experts Actually Think, the Science of Magic. There is this famous cognitive psychology study that perfectly illustrates the difference in how experts and novices think. Researchers took advanced physics PhDs and undergraduate students and asked both groups to sort a bunch of physics problems into categories. The results were super revealing. The novices, the undergrads, they categorized the problems by totally superficial features like, oh, this one has a pulley or this one has an inclined plane. But the experts, they instantly looked right past the surface. They categorized the problems by deep underlying laws, like the conservation of energy. Because the experts were zeroing in on those core principles right away, they could just jump straight to the correct problem-solving approach, whereas the novices were stuck relying on slow, painful trial and error. So how do you actually build that kind of ability? How do you instantly see deep principles? Well, it comes down to a staggering number, 50,000. Researchers estimate that 50,000 is the massive library of mental chunks, or stored patterns, that a chess grandmaster holds in their long-term memory. It's just this enormous database of past experience. When a grandmaster looks at a board, they aren't actually calculating a million moves ahead like a supercomputer. They're simply recognizing one of these 50,000 patterns. And that instantaneous recognition, that is exactly what we experience as intuition. But here is the real catch, and it honestly shatters that whole illusion of genius. If you take that exact same chessboard and just randomize the pieces, putting them in bizarre positions that would never naturally happen in a real game, the grandmaster's advantage completely disappears. Their intuition totally fails them. And why? Because they suddenly don't have a stored pattern to pull from. So intuition isn't magic at all. It is literally just the product of a vast, highly organized, internalized library of real-world experience.
Which brings us to Section 2, the trap of brittle learning.
Brittle learning is exactly what it sounds like. It's what happens when you just memorize textbook facts or formulas without actually understanding how they apply in the real world. And Richard Feynman absolutely hated brittle learning. There's this great anecdote from the source material where Feynman actually tricked his classmates. He held up a French curve, which is just a plastic template you use for drawing smooth curves, and he told them it was this incredibly special object, because no matter how you hold it, the bottom is always tangent to a horizontal line. And his classmates were absolutely blown away. But Feynman was just shaking his head. He knew that this was simply an elementary fact of calculus that applies to literally any smooth shape. His classmates had memorized all these calculus rules to pass their exams, but their knowledge was so brittle they couldn't even recognize those rules when they were applied to a physical object right in front of them. And this kind of brittle learning leads straight into a really uncomfortable psychological phenomenon called the illusion of explanatory depth. This is basically the mistaken belief that you fully understand a concept, right up until you are actually forced to explain it. Think about a bicycle. You know what a bicycle is, right? But if I handed you a pen and paper right now and said, okay, draw exactly how the chain connects to the pedals and the gears to make the wheels turn, could you do it? The truth is, most people can't. We walk around all day tricking ourselves into thinking we understand things just because we're familiar with the vocabulary. So to defeat this illusion, we have to fundamentally change how we process information. Check out this fascinating memory study on something called the levels of processing effect. Researchers gave two groups of people a list of words. The first group was asked to just look at the words and note if they contained the letter E, a super shallow, superficial task, right? But the second group was asked to rate how pleasant the meaning of the word was, a task that actually forces you to deeply process the concept. And the result? The group that processed the deeper meaning remembered almost twice as many words. Deeply processing meaning practically doubles your retention compared to just shallow scanning. Moving on to Section 3, the reveal, digging deep before building up. Okay, so how exactly did the magician do it? Well, Feynman had this grueling but highly effective set of habits. First off, he absolutely refused to just nod along with a textbook. Instead of passively reading a result, he would actively force himself to mentally recreate that result from scratch. He would prove propositions himself. And crucially, if a textbook didn't provide a concrete, real-world example of a complex math problem, Feynman would just invent one in his head and follow it all the way through to see what the math was actually doing. He literally refused to accept that he understood something until he could build it himself. And what's really amazing here is that Feynman wasn't the only one doing this. As a child, Albert Einstein built his own legendary intuition using this exact same rigorous method. Einstein spent his early years personally trying to prove the Pythagorean theorem based on similar triangles, rather than just taking his teacher's word for it. This brilliantly illustrates that genius, intuition, is definitely not some genetic lottery ticket. It's the direct result of a repeatable, structured habit of relentlessly digging deep into the material. Let's break this down in Section 4, the masterclass, the Feynman technique. So let's walk through the 4 steps of the actual Feynman technique. This is a highly actionable framework straight from our source material that you can use to cure your own illusions of explanatory depth. Step 1, just write the concept down on a blank piece of paper. Step 2, explain the idea out loud or in writing as if you were teaching it to a layman, someone who has zero background in the subject. Step 3, now this is the magic step. When you inevitably get stuck and realize you actually can't explain a certain part, go back to your textbook or source material and relearn it until you can. And finally, Step 4, simplify your language and create a real-world analogy to tie it all together. This deliberate step-by-step process forces you to build that deep connective tissue between ideas that true experts rely on. Now, obviously, you aren't going to do this for every single fact you ever learn. The source material outlines 3 specific, highly versatile scenarios where deploying this technique is going to give you the maximum return on your time. You use it for things you don't understand at all, for problems you just can't seem to solve, and for expanding your core intuition on vital concepts. Let's look at how you might adapt the technique for those first 2 scenarios. First up, what if you are just totally baffled by a topic, like you have no idea what's going on? The author of our source material actually ran into this while studying a super complex machine vision concept called photogrammetry. He was totally lost, so he adopted the Feynman technique. Instead of closing the book, he kept the textbook open right next to him while he wrote out his layman's explanation. By going back and forth, writing out the broad strokes in his own words, he was able to untangle all that baffling academic prose and actually grasp the mechanics of the idea. Second, what if you were just stuck on a really difficult problem or procedure? Here, you can use the Feynman technique to walk through a concrete visual example. The author was struggling with this complex computer graphics algorithm called grid acceleration. So he just drew a picture of a little snowman being rendered by a camera, and then he walked step by step through the math alongside his visual drawing. By forcing himself to explain the algorithm using a concrete example, the snowman, the abstract math suddenly made perfect intuitive sense. You know, when we look at Feynman's incredibly playful style, it's so easy to think his learning was just effortless. But that is the ultimate myth. Feynman's true superpower was his willingness to relentlessly, aggressively practice the basics. I mean, he even applied this to his hobbies. When he decided he wanted to learn how to pick locks, he literally sat there and systematically trained his hands to go through all the possible combinations, over and over again, until it became instinctual. The magic wasn't magic at all. It was just hard work, deeply processed. So I leave you with this. What will you truly understand today? As we've seen, genius-level intuition isn't some mystical gift from the universe. It's simply the result of refusing to accept brittle, surface-level knowledge. It's about grabbing a blank piece of paper, deploying the Feynman technique, and forcing yourself to confront your own illusion of explanatory depth. So pick a topic you've been struggling with, grab a pen, and start building your own unshakable intuition. Thanks for joining me on this explainer, and keep learning deeply.